Hello guys, welcome to Random Shoki. So today we'll be working with ANSYS and we'll be doing structure analysis of a beam. So let's get started. So let me open up ANSYS first. So here on the menu, just drag and drop static structural on which we are going to do the structure analysis of the beam. So here you have engineering data, geometry, model setup and such. I'll open up engineering data. Here you'll have the material properties of the material which you're going to use. So I'm going to keep it to default for structural steel. You can add your materials if needed. So next thing we'll be doing on the geometry. So we'll use design modeler to create the geometry of the beam. So we'll open that now. So you open the design modeler. So here we're gonna, it's similar to CATIA, AutoCAD and such. So we'll just do some sketching. So we'll do it in the XY plane. We'll create a rectangle of 50 across 5 meter. We'll constrain them using dimensions. So that will be H1, that will be V1. So H1 is 50, V2 actually. V2 is 5 meter. Click on generate. So now after this, we're gonna give some thickness to this. So ISO, extrude, and we're gonna give that 5 meter. And click on generate. So now we have our beam, a simple rectangular beam. So you can just close this now. Oh no, before closing, we'll just split the faces. So for splitting face, we are gonna need some lines. So we're gonna draw the lines on the top face of the rectangle. So there's one. We'll do 4 lines. So that we'll get somewhere around 6 faces. 1, 2, 3, 4, 5, 6. Yeah. So now we are gonna constrain those. Let's keep them equidistant. Wait, not this. No, no, nope. Just delete that. Constraints. Yeah, equal length. So um, we have our lines. So we're gonna click on generate now. So now go to tools, and there'll be an option called face split. So the target face is the top face, and the tool geometry will be the lines which we did now. Make sure you're gonna choose the edge selector option there, or else you'll be sitting there for hours or such. Just click on those, apply, generate. So as you can see, we have now generated 6 different faces. Actually 5. Okay, we'll close this now. So next we'll open up model. This is where we're gonna do the meshing and add the forces and such. We'll wait for it to open. Yeah, so here's a model. So let's generate a mesh. I'll give the size 0.25. The smaller the mesh size, the better the results. So I'll generate the mesh. Yeah, and the smaller the size you give, the more time it takes. Okay, so that is a simple mesh. If you want, you can go with unstructured mesh and do some refinement if you need. So now I'll add the forces first. I'm gonna make a fixed support on two edges. First select the edge selector, then at the bottom there and there. Oh, here again, and click on apply. So we have a fixed support now. Now let me insert forces. Force. Okay. So I'm gonna select the all the five faces on top. So this would be uniform load and click on apply, and I'll be giving 1500 newtons. So apply direction. I'll choose downward direction. Click on the face, reverse direction, apply. You can actually give what is that? You can go to your analysis setting and give the number of steps you need. So I think I'll be changing it to 10, not 5. Hmm. Okay. Here you can change the forces at what time, what force will be applied over there. So I'll choose 5,000, 1,200, 1,400, 1,600, and 1,800. So after that, I'm gonna, yeah, insert total deformation. So that's what you're gonna need. So I'll click on solve. This is gonna take some time. Writing report. So here's your solution. So your total deformation is shown there. So let's change the way how it looks. So we'll go to result, change the from show elements to undeformed model. So here you have the, and then you're gonna smooth the contours. So the maximum total deformation is shown here. So, and we'll play the animation of it. So here's the animation. So the next we'll go for result generation. For that, you'll need to go to home. Then first thing, your units. You can change the units from meter to millimeter and such, which is required for you. So there's a report preview, which also generates the report for the done project work. So this is how your report is going to look. It's going to have all the material properties and all the tabulated data you need, the graphs, everything. You can print it or you can just save as a PDF. So I'll close this. So this is one case. So let's do another case now. Let me just delete the force there. I'll make the time number of steps to 1. So yeah, now I'll insert force. Um, on, so I'll make it a two part. So on the first two faces, it's going to be different. somewhere around 1500 Newton, and the direction is downward. Apply, and then again I'm gonna insert force on the second phase. Apply. So even this is gonna be 1500 downward. On the next two sides again I'm gonna apply forces. Downward, apply, solve. So this is the deformation of forces acting on the three faces on the one corner of the beam. So similar to this, you can do various cases, and this is the animation of the beam bending. All right, okay, pause. Let me remove those two forces now. Let's check for another case now. Yes, delete, insert force, force. Yes, I'm gonna select that and that face. Yes, I'm gonna give that as magnitude of 3000 Newton, downward direction. So I'm gonna insert another force on the other two faces such that it looks as a varying load. So here I'm gonna give it as somewhere around 2500 Newton, downward again. Mm, reverse, yes, apply. So now solve. For those two, there will be just a deformation. And here you have for a varying load. So now I'm gonna remove both the forces. Remove the fixed support. Yes. Let the forces be. I'm just gonna remove the fixed support and make this a cantilever beam by fixing one face. So insert fixed support. So yeah, now it's a cantilever beam. One face is fixed, and now I see. Now I'm gonna solve it. Now before that, I'm gonna change the force. Magnitude will be 4000 for this, and the other one will be 3000. Yeah, 3000. Okay. Okay, let's go with 2000. Solve. And now we have the deformation for cantilever beam of two varying loads. This should be the deformation. Let me quickly play the animation here. Uh, I'll change it to 5000 now, and that will be 5000 for uniform load on the beam. So yes, solve. And now we have uniform bending, uniform deformation. Let me play the animation now. There it is. So I'll delete force 2, force 1, delete. Yes. So I'm gonna add a compressive load. So I'm gonna insert force, yes, on the opposite side of the fixed support. Let it be 50,000 Newton. So the direction would be inward and solve. And now this is the deformation for a compressive load acting on a cantilever beam. I'll play the animation now. It's gonna take some time to load. So yeah, home, isometric. So this is the animation for the compressive load. So these are some simple cases of forces acting on a cantilever beam. So now we are gonna go for a cylindrical beam. So let me just close this. Let's try a thin walled cylinder now. So close. Let me just rename this and save it. Rename. Beam structural analysis. All right. Okay. And I'll just save it now. So now you're gonna do it for a thin walled cylindrical beam. Let me drag and drop static structural right now. So let's open up design modeler. Okay, so let's start sketching. Sketching. So let's draw a circle. Where is it? Here. Circle dimensions. Let's give it a diameter of 20 meter. And generate. Okay. So before extruding, let's make it ISO. Extrude. So let's extrude up to 50 meter. Okay. So thin walled, yes. Let's make the inward thickness to be, let's see, 1 meter. Okay. And generate. There you have your thin walled cylinder, right? So now we need to move the plane to the center to make another circle for splitting the face. So XY plane, move offset from Z direction. So let the value be half, which is 25 meter. Okay, generate. So we have a new plane there. Let's do sketch a circle from the center, 20 meters, dimensions. Let the now be 20 meter. Okay. So generate. Now we're gonna do the face split. Tools, face split, and the target face is the that one. Apply, tool geometry. Make sure to click on edge selection. There, select that circle. Apply, generate. And now you have two faces on the cylinder. Yes. All right. Close this. We'll open modeling now. So let's zoom out. Okay, so first thing, let's mesh it. Okay, mesh. Let's give the same size of 0.025. All right, update. It's gonna take some time. All right, it's done. So as you can see, this is one fine mesh for the structure. Now we're gonna insert some loads or forces. Okay, let's give a moment for one phase and the other phase. Insert moment. Actually, a fixed support on one phase. Let's say, let's get on that phase. Nope, not that. That one. Apply. Now display home ISO. All right. Now insert. Where is it? Moment. There it is. So select that face and that face. Apply. Let the moment be 1500 and the direction, let it be inward. Okay, apply, and let's do the total deformation and solve. So here you have the result for moment. So this is your total deformation. So let me just play the animation quickly. So here's the animation for the moment acting on the cylindrical beam, thin wall beam. If you need results for various forces or moments, you can just go there and add those according to your requirements. So I'm just going with the basics here. So I'll just remove, make the fixed support to be at the center. Let me just choose it. Edge, yes, and apply. I'll just make that moment to be on one side, apply, and insert another moment to be on the other face. So that's gonna be in the negative 1500 and the direction will be inward again. And now solve. Okay, we'll just close. So here's a solution for that. Solution for fixing the center and giving moment on both the directions. So I'll just play the animation now. So this is the animation for that. Okay, so now, okay, now we are gonna do a linearized deformation. So for that, we're gonna need a path. Before that, let me just right click, insert linearized stress equivalent. All right. For this, you're going to be needing a path for that. Uh, Not here. Right click on okay, not here. Right click on model, insert construction geometry, path. So for the path, let's select the start and end faces. So let that be the start. All right. So this is if this were a complete solid body, we wouldn't need to do much changes here. Since there's a hollow section, we're gonna go to the path, right click, snap to edges. So this is gonna make sure the path is lying on the solid body. After that, let me just add this equivalent stress. All right. So select the path there, click solve. So there is a linearized equivalent stress. So that's how you're gonna do that. This will be helpful in shafts, analysis of shafts and such. Alright, so thank you for watching Random Shoki, and yeah, give it a thumbs up. See you in the next video. Awesome.